All right, welcome to the Robert Show, and it is New Year. First of all, welcome Mona. To we are back for our data quality series. We are doing this, and I'm super excited about the topic. But first of all, Happy New Year, and welcome to the show again.
Happy New Year, Rohit. It's an exciting new year. Pretty excited to start this year with this podcast, literally on the first working day of the year. So let's get rolling.
Exactly, and I'm excited because of the topic. We've heard so much about open architecture, open data formats. There have been such massive announcements. I was at AWS reInvent just last month, and we all have seen the announcements, and that's why I decided that I definitely want to do this. This sort of panel discussion where I can invite the best leaders in the space. Who can talk about open architecture, open data formats. I know Telmai also does a lot in the iceberg space. So also wanted to have you co-host this session. So we are here. What I'm going to do for next steps is going to get our panelists up here. So without any further ado,
I'll just
let's.
add one thing, Ravit. For the audience, as a part of the data quality series, today's topic is how do we ensure data quality as we are adopting the open architectures and specifically open data formats. So, really setting the stage for that topic that we have panelists, we have really, really credible and the best of the class folks for this topic. There's a lot of discussion around this. It still goes in that theme. So, let's roll and get the panelist on.
Fantastic. Thanks, Mona, for adding that. I'm gonna get bring up our first panelist, Pete, who's the CDO at Microsoft Netherlands, and also the author of Data Management at Scale. And here we go. Pete, welcome to the Robert Show.
Hello.
Super excited to host you today and learn more about the topics that we have and we are discussing today. Would you like to quickly introduce yourself? Tell us more about yourself to our audience here.
Well, thank you, Ravit and Mona, for having me here, first of all. Happy to talk about open table formats. Data quality is a topic which is close to my heart, data governance. So maybe to kick off, I have a background in data management, data engineering. I used to work for big banks, consultancy firms. Now I'm currently in the role of Chief Data Officer at Microsoft the Netherlands. I must admit it's a commercial role. Sometimes people think I, as a CDO at Microsoft the Netherlands, manage a lot of data. No, I work with customers specifically in this field. Also, thanks for mentioning, name dropping the book, Data Management at Scale. Also, I'm working on a new book called Building Medallion Architectures. Nice
Nice.
subject, and also open tables. Open table formats for sure will be also discussed in that book.
By the way,
Fantastic.
Pete, you write really awesome articles. The first time
Thanks a lot.
I got introduced to you was I was on a flight and I read your article, and I had even the boring journey of the flight had suddenly become interesting when I read about one of your wonderful blog posts on the medallion architecture and how data quality should be thought through that architecture.
Nice. Well, this book really goes beyond that subject. So it's very technical, must admit, but a bit unlike the other articles and books I've published before, which are a bit more abstract and conceptual. This one is really hands-on with screenshots, code snippets. So if you want to read it and use it, you need to roll up your sleeves and get your hands dirty for sure.
Absolutely. Looking forward.
That's awesome. Pete, once again, welcome. I'm going to introduce our second panelist for today, Scott Haines, who's a distinguished software engineer at Nike, a thought leader in streaming and data lake technologies. Let's bring up Scott here. Scott, welcome to the Robert Show.
Hey, thanks for having me on. Just thanks again to everybody. I know this is a very long, kind of overdue panel. We were going to do this in December, and now here we are in January doing it. But I'm much happier to do this as like a way of starting the year versus a way of kind of closing out the year before. So it's, happy accidents and things like that. So let's see. I've been in the essentially data space for about 20 years, working on data quality before data quality was a thing, really.
Nice.
It's like, how do you create systems that just always work? How do you create, consistency, reliability, and how do you encode that into what it is that you actually build? Because it's one of the tenets of software, right? It's like, we know something is getting better every time we make a change. If there's a bug, we can always fix it. And the same thing goes for data. an attitude that I've adopted at running creating systems and now working on kind of end-to-end data platforms. Also, also tech reviewer for the new one for the Medallion Architecture book, and happy to be here.
And Scott, you have written a book recently, right? You published something as well on the Delta Lake.
Yeah, like I have it. Like, yay. This guy, the Delta Lake, the Definitive Guide.
I have it.
Fantastic book.
Yay. Thank you, everybody. I wrote another one back in the day as well, which I also have, just as like a show and tell, which is like the first book I ever wrote, which was on just building streaming systems with Spark.
Nice.
This one's hands-on. It's 600 pages. Did not do very well just because it was all in Scala. And I think most of the data engineering community is in Python. And so reviews were very much like, why is it in Java? Why is it in Scala? I don't want the JVM. I'm like, no one wants the JVM. And so it's like, okay, great. So moving on from there, I'm just happy to be here. So thanks for having me.
Awesome. I'm going to get our third panelist up here, Pankaj Yawale, who's the Director of Data Architecture at ZoomInfo, a pioneer in handling large-scale data environments. So without any further ado, let's bring up Pankaj. Welcome to the Robert Show. So excited to chat with you today.
Yeah, hi everyone, and thank you, Ravit and Mona, for having me at this podcast today. It's an honor to be with you, and as well as great people such as Pete and Scott. Just to introduce myself quickly, I'm actually a senior principal architect at ZoomInfo. There's a bit of a title change. So I look into I always say this. Mona has probably noticed it. When we talk about any system or technology, my focus is on both functional and non-functional aspects. So that's what I do. I look into the functional and non-functional aspects of the data processing systems that we build at ZoomInfo here. I have been in the industry for a long time, 20 plus years, building data platforms at scale for the last 11 to 12 years. Started back in 2013 when, Spark was 1.0, Kafka was 1.0, Hadoop was probably 2.0 or something like that. There was no EMR, there was no data prog, just everything on-prem. And then it has been a wonderful journey of, seeing things working in cloud so easily for, the new generation that they don't have to get their hands, as dirty as that we used to get at the time. I'm also excited to talk about everything open, specifically open architecture, because open source is not enough. We will probably get into, what does it mean by being open source versus open architecture. So I'm very excited to kind of, drill down further on that concept and share my thoughts on that as well.
And Pankaj, you have, remind me, you have embarked on the journey of open data formats. So you've started adopting Iceberg, and in the past also you've used a few others, right?
We have, yes. So, we have a long history of, data processing. When Iceberg wasn't a thing, we still had data products. And some of them got packaged using some proprietary technologies, and some of them got packaged using some open source format, but not to the extent that, we call it open today, like Iceberg, right? So we started that journey of building all our data products as Iceberg so that we are not limited to one interface using which we can consume or query that data, right? So we could plug in anything onto Iceberg, for example, Telmai, right? Another example is Starburst. It's very easy to put these tools on top of your data if your data is in standard open format, because there is an ecosystem that supports it, which to me is a key differentiator if you really want to get value out of your data fast and with greater accuracy.
Makes sense.
That's awesome.
Welcome again. I cannot tell you what an honor it is. And I will just add one thing, like having spoken to so many different personas within the data ecosystem, I love the architect perspective because it is more broader usually. And as Pankaj pointed out, the functional plus the technical aspect coming together to solve real business problems. So excited. Let's get this started. Let's talk open data formats.
Super excited. Thanks, Mona, for iterating that. And I'm going to start with a very fundamental question that I had, and that could be we can start with everyone answering this one is about how does open data architecture mean? What does it mean to you, first of all, and why does it matter in today's world? What do you think? Maybe Scott, what do you think?
Yeah, so I think with this, Pankaj talked a little bit more about this as well, like when during his introduction. But like open, I think about it as like there's a portability aspect for any sort of open architecture. A lot of times, it's also built on like open formats. Back in the day, we talked more about interoperability. You think about that like with APIs, right? There's an interface for all of that. In the same way, like if you want to be able to plug something into your architecture, it shouldn't be something that is going to require you to, pay solutions architects at a different company to go and do it. You can do that, but you shouldn't have to have, only one side of like the partnership, understanding how things actually come together. And so with a lot of that, like it's more kind of like there's an educational aspect. A lot of times also things are extensible. If things don't work the way that you want them, you can extend them. And then the last part too is that it's all that there's that transparency aspect too, where I know exactly how things are running because I've either run the unit tests myself. I've seen these things running in production. I understand there's like really no surprises when things are actually running. On the other side of that, you have kind of closed off systems where things work, and you take that you take it for granted that things actually work, but when things go wrong, it's another one of those things where you can't go and debug it yourself. You have to go and then ask somebody else to do it, which is just, changes a lot of things with like, mean time to, recovery, any other metrics you have, during an outage. And so just in general, things are open, remain open, and you can also upgrade like individual components, given that everything's interoperable. So that's
very interesting
on it.
I think that's very interesting, Scott. Thanks for sharing that. Pankaj, what do you think? How would you like to add? I know you mentioned a little about how y'all are using it already and how y'all have been already doing it since a while. But what do you think about the current situation and why does it matter?
Yeah. Open architecture in terms of data is a key differentiator if you really want to get value out of your data, right? I mean, there are a ton of data engines, data warehouses, databases out there. You can process some of your data and then package it and put it into a database, and then you are only limited to that technology in terms of using your data, in terms of building explorations and other ad hoc use cases on top of that data.
Right.
Which basically puts a lot of limitations on you. And then what you end up doing is then you end up building another system in parallel to that, which takes a lot of resources, capacity, and funding just to enable a few more use cases, right? And then you keep on doing it. And that's what has been happening for the last 10 years, I would say. So why not do it the right way from the beginning so that you don't have any limitations and you just basically, whatever you have to do, you just do it on the top of the data that you have already packaged. All the energy went into packaging that data, like productizing that data. Then why put that energy again and again? And that is where these open formats such as Iceberg really helps because there is like an ecosystem built around Iceberg, right? Whether you have a process, data processing pipeline built in Spark, you can write data into Iceberg, right? Iceberg is basically just a data lake, like just some files and metadata sitting in a bucket. But then your processes can also manage that data by writing into an Iceberg location. At the same time, the consumer, the interfaces can also query that data, even exactly at that moment, right, without any delay. And I think that enables this new paradigm of, putting your data product on a really, fast kind of a conveyor belt, right, where you quickly produce data, package it, and make it available, and not wait for teams and people to build systems for months and months. One thing to add about is that, I kind of, was hitting upon it, that there is a difference between open source and open architecture. There are a lot of things that are open source, but it's not easy to build an ecosystem around it because the integration points are not designed correctly, right? So open architecture to me is a tool or technology that is open source, but it is also designed in a way that you can build an ecosystem out of it. Perfect example is Kafka. I mean, it came out in 2014. Look where Kafka is today. There are so many things. There is the KSQL, there is the connector, there is that, and there are third-party vendors like MongoDB. They are building their ingestion processes using Kafka and off of Kafka. So that to me is real open architecture. And again, since Mona is here, Telmai supports pretty much everything, right, in terms of data. If you want to read data from anywhere, they support it. And then they also exposes the capability using like really nice integrations through APIs. And they can also fit well into your data processing paradigm, such as Airflow DAGs and everything. So that to me is like open architecture.
Nice. Pankaj, great insights for sure. And you mentioned about, obviously some very interesting points. I'll get that over, but since you mentioned about Telmai, I'm going to go to Mona now and ask about what are your thoughts, Mona, when you're looking at a customer perspective? What are customers asking? How are you looking at open data architecture being this big thing? And we've seen like so many different announcements over 2024 and before that as well. How do you envision it from a point of view of a vendor, but not only just that, because it's an open source community? How do you look at it, and how are you all taking it to the next level?
Yeah, so I can tell you the shift has been dramatic. Like when we started Telmai, all credits to my co-founder Max, who's a technologist at heart, architectural and thinking. He really wanted to build Telmai right, and he was like, "Look, we need to empower our economic buyer to make their decisions, whether they want to use streaming, whether they want to use like SQL-based data sources, whether columnar or whatever. We are not going to limit their architectural decisions because of Telma. So we just need to naturally fit into their ecosystem." So that was an
Right.
early on decision we made, but we didn't see that shift happening that rapidly, to be honest, when we started Telma. But the last
Mm-hmm.
2 years has been phenomenal. Like everybody, the adoption
Exactly.
of open data formats. Delta was one of our, like we started seeing Delta a lot in our customer conversations. And people had started seeing the benefits of leveraging Delta as their data lake strategy as in Delta format. Hoodie started coming in the end, it was like the large companies pushing, like Netflix and others adopting it, but people started seeing it like the benefit of moving with this, decoupling with this. And now pretty much most of our conversations are like starting like this: that do you support open formats? How is your integration with Iceberg? So I almost felt like some of these architectural decisions give a lot of long-term dividends. And anytime, as a vendor, we want to make sure that people have to be in control, not us. We don't need to tell our users that what they need to make choice, because Pete, you know this. You are working with so many different
Yes.
customers. Each customer use case, even in the same vertical, is going to force them to use a different technology, whether it's for streaming use case, whether it's for batch use case, storage for different data set. Giving them that freedom, to me, that is the open architecture fundamentally. So open source, no open source, composability, flexibility, decision making power on the architecture, all of that kind of builds the foundation, to me, of open architecture, of being open.
Yeah. What we miss
Amazing.
still is, I feel, if I may add something, so all of the things you have said, brilliant, but we miss a lot of open standards, especially when it comes to metadata
Yeah.
and cataloging. Right now, okay, great, we have open catalogs, but still we lack lots of open meta standards, open metadata standards when it comes to synchronizing catalogs. Say the semantic context over your data products, a glossary, for instance. Why don't we have yet an open standard for that?
Mm-hmm.
And I think this misses still and is really essential when it comes to using data at scale and working in an ecosystem with many partners. You would like to not only give them the data as well, the context, semantic context of that data. And also for AI, I feel this is critically important. So these models need to know also the context in which the data was created. And also for that, we miss currently open metadata standards.
Makes sense.
I think that's a good addition, Pete. So thanks for that. Also, quickly wanting to learn a little about, since we are on the topic of open architecture and the architectural, changes that are needed. What do you guys think about architectural changes that are needed in the next gen AI systems? Because obviously, AI is the talk of the town. I go to conferences, everyone talk about architectures, open architecture, and then they kind of shift the conversation to AI. And talking about data quality and AI kind of plays a very important role. So, what are your thoughts about that? Kind of curious to know. Maybe this time, Pete, you can share your thoughts first.
No real standard yet we have for, I think, unstructured data is what I see mainly among my customers. When they layer their unstructured data, they start ingesting their raw documents, PDF, Word files, and then usually in the second layer, so the silver layer, we speak in medallion terms, I see customers convert all of that unstructured data to a markup language. Markdown is used quite a lot, or XML. But it would be nice to have an open standard for unstructured data. And why it's important, because I feel at some point we would like to programmatically revise maybe that content or restructure it or duplicate it or summarize it with maybe LLMs or frameworks. And for that, we need to have open standards, also for the interoperability. And then moving on, let's say, to the gold layer, so the last layer where that unstructured data is being served to LLMs. Yeah, we vectorize, we store it in vector databases, but also I think there we need to have more open standards. So we don't have yet, I think, an widely embraced open vector format. There are some open source technologies, but there's no open source vector format yet, I feel.
And
But maybe Scott.
Pete, is your point that the evolution is still happening for the data in general, specifically unstructured? The way I'm hearing you is that unstructured data, we are all kind of now moving very aggressively towards more and more unstructured data, and we still haven't reached that maturity where I do feel, honestly, for structured and semi-structured data, there's a lot more best practices, architectural recommendations. We've read a lot, and I think we are early on that cycle. Is that right? Or
Yes, absolutely. And customers struggle really with this subject. So my best practice I give to customers, try to harmonize the disciplines for unstructured data management and structured data management, because there's a wealth of overlapping disciplines. Data quality, for instance, metadata management, it's all important. But still, often I see those are then two distinct disciplines delegated to different teams, even sometimes within the organization. And this is far from ideal, because my strong belief is in the future, LLMs or smart agents, they will work with both structured and unstructured data. Now, short term, I see lots of customers, they look at unstructured data, but my strong belief is over time, this will shift to using as well structured data in the realm of using agents at large. Yeah. So
Nice.
there we need to catch up.
No, fantastic insights, Pete. Thanks for sharing that. Scott, what do you think about the architectural changes that are needed for the next gen AI systems?
Yeah, so I mean, let's just kind of extend and keep on going where Pete set us up. So I agree with the in a world where it's like, we struggled originally just to kind of figure out semi-structured, structured, then going into completely unstructured. We still need to create structure from unstructured, and then that is essentially kind of like, it's bespoke for solving specific problems in the absence of those standards. It's like if you think about like SVM like there's like other formats and types that were created for specific learning algorithms back in the day. Now is 15, 20 years ago, but I don't see the same sort of thing as well. And so it's like you have like different kind of proprietary companies that are going to take any kind of doc. So scanning forms for onboarding, for a company, for example, reading through W-2s, W-9s, any of the other like, tax documents, things like that, things that people aren't necessarily, reading things that people don't want other people to actually have to see. So it's like, I can auto scan this, we can clear PII before anything else actually shows up for people. That's great, but that's going to all be different. So I guess what would I'll put this back to you, Pete. So in terms of creating structure from, specific unstructured categories, say, specific types of documents, what would be your go-to to solve that problem? Like you brought up Markdown before. Would it be Markdown plus like annotations or tags? Like what would it look like?
Mainly what I see now among my customers, it's indeed Markdown as a language, sometimes LaTeX or XML in fewer cases. And then next to that, there's lots of metadata that's being generated. Where that metadata, how that is managed and stored, that very much depends. So sometimes they store it as extra metadata files within those folders where all of these unstructured documents sit within. In other cases, they store it in a metadata store or meta store. Could be in MySQL database or a SQL database, for instance. Moving forward, I expect the catalog to play a big role there. But unfortunately, today's catalogs are very much pivoted towards structured data. They work really well with open table formats. But unstructured data, it's overseen currently. So there, all of the vendors call out, you need to step up and make improvements to the catalogs for unstructured data management.
Awesome.
That's very interesting.
I think, Scott, you also bring a very good point about like when it's unstructured data, how do you control the sensitivity of the data and like PII data sliding into your models, and like because we are taking a bunch of documents, pushing it out, and it's obviously some of these models have made things so easy to just give access to some of your email chains and like see if you can get some information about policies and what next best steps you could do. But there's that risk of we still haven't figured out how to control what gets passed, and controlling that is an important aspect of and I don't know if it's purely architectural, but it is definitely a part of building robust, reliable solution through this.
For sure. I think, I mean, if we want to talk a little bit more about catalogs as well, like I think, kind of joining, like combining everything else together, it's, kind of the central brain for how we work with data. So whether it's adding that metadata for unstructured data, or if it's adding, classification models for, types of entities that we see, whether it's, emails, it's addresses, it's locales, it's, latitude, longitudes, like IP addresses, like all the things that we think as harmful or harmful within context to specific governance rules, that also has to live somewhere. And those same pipelines, like whether you're running a decentralized system, we still need to have that central catalog to be able to help, establish, rules. It's kind of like society, right? There's rules, we should follow them. Sometimes we don't and things go bad. So we don't have to go down that direction, but I'm going to kick this over to Pankaj as well. So what are your thoughts?
Okay, thanks, Scott. So I think one thing that's missing today is lineage. When it comes to unstructured data, the metadata of unstructured data is still structured, meaning that you could still establish lineage even with structured data and unstructured data. For example, let's think of the RAG use cases where you augment your queries with additional data. If that additional data is being like a chapter in a book, then that's like one section. And then if you consider each page as a document about which you already have the metadata, then that's a lineage. So you can then trace back what was augmented within the query, let's say chapter 2 and 4 pages. Then later you can, if the response was, the response came out to be unethical or questionable, then you can go back and find out what was augmented, that what of the query augmented with, and what chapter was referenced in the augmentation of that query. Then you can trace back the issue. Without the lineage, you have no visibility into what happened right in the past if you have to do some postmortem of the responses that your LLM models are spitting out. So, and I came up with this novel, record level lineage architecture, which I also presented at Data Universe in New York, as well as ODSC conference here in Boston. So that time that was probably a year ago, and LLM was still new, like Gen AI use cases being considered for, such a variety of landscape was kind of still new. But a thought came to me that, I think the record level lineage would also basically enable these Gen AI use cases where you need some visibility into what's happening when you answer your queries. So I think lineage is one of the architectural component that is still missing, and I think it will be a critical component very soon that people will start realizing.
I couldn't agree more.
Yeah.
I have a follow-up question then. How does the open format is enabling some of this more aggressively? If I look at like some of the conversations I have, most typical things is that people push data into the data lake. And this could be for analytical use case, AI use case, or whatever. The first thing is like take data from many sources, dump it into a lake, low cost, manage it there. Then you push it. I have seen a pattern where then you push that into your analytical engine, whether it's data warehouse, Redshift, Snowflake, or any of those, and then use it for the reporting dashboard and all of that. Now with the AI use cases coming, is the open format and data lake becoming more and more de facto for most of your stuff? And even with a good processing engines right there, what happens to that second part of the pipeline? And maybe this is a peaked question also, given that you are writing so much about the medallion architecture, bronze. How do you see that evolve?
What I see, mainly the pattern like you described it. So customers, they push first all of their documents into either a landing area, or you could call that the bronze layer. It's all raw. At that point of capturing the data, often it's important, I see, you classify that data and the origin and the capturing date, so the date of origination you would like to have. But there usually it ends. And from there it segues in, I see, mainly into two routes. So less mature customers, they take that data immediately, chunk, embed it, factorize it, and then let LLMs talk to that data. I think that's a missed opportunity because you make it very specific immediately for a set of use cases, and there's barely any reuse possible instead of going back to that very raw technical data. Other more mature customers, I see, they take those raw documents, which are as well in many different formats. So you see PDF, XML, docx, you name it, log files, it could be anything. And they all transform it into a new technical standards. And nowadays, I see mainly that's a markup language. So let's say Markdown. In that process, they chunk it as well, but not chunking in a way making it specific for the LLMs, but chunking it more to manage it better. So a very lengthy document, for instance, is chunked into several pieces. And why? Because you would like to do maybe fine-grained controls on certain chapters or pieces of the document, or you would like to classify not the whole document, but certain pieces of that. They do entity extraction. So lots of post processes run after they have converted all of that technical data into a set of common technical files, unstructured data. There it then ends, and then the next step is you make it specific for that the LLM. The issue there is you need to apply an embedding model and a chunking strategy that's very specific to the business problem you would like to solve. You could not easily generalize the chunking strategy and choose an embedding model in a way that you could use it for many, many agents. So you need to think well about what is the business problem I would like to solve, what data is needed for that, and what is the right chunking strategy, for instance, I would like to apply on that data. So for the use cases, each time I see organizations, they follow a specific path. Well, that silver intermediate layer, that's kept generic for all of the subsequent use cases and agents that will be built next to that. That's a long, lengthy answer, and I've
Yeah.
way
And
more
if I
details
have
about
to,
this in my new book, but this is high level what I see among my customers.
yeah, so Pete, really summarizing, like in this case, the concepts are similar of the layers, but what
Yes.
we do at each layer is changing for the AI use cases, is what I'm hearing, and
Yes,
with the
and
specifics that you noted.
I'm also a
Makes
bit reserved whether we will see for that last layer really an open. I think yes, there will be an open standard, and we can easily vectorize and store that data. But is that then a data product you can generalize and use for tons of use cases? I'm a bit doubtful, huh? Knowing the specifics of how LLMs and agents work and data must be collected and designed for that. So yes, we miss an open standard, but you should be cautious and not fall in the trap of generalizing on one hand for all of the specific use cases that come at the end.
Makes sense.
That's awesome. I think Peter, you've kind of well summed in terms of the question that Mona kind of put out. I'm kind of curious, around, since we are on this topic of open architecture, but also I'm curious to learn a little about data quality. And since Pankaj is here, I know ZoomInfo kind of handle a lot of data quality issues. So Pankaj, I have a curious question for you, and an open question actually around ZoomInfo handling data quality. So how do you kind of do it? Would you like to tell us a little about that as well, so I can connect the dots with if you've kind of moved to the open formats, how does what was that shift like? What were the challenges that you faced as well?
Sure. Yeah. I mean, yeah, the ZoomInfo, we are a data company, right? So we gather, collect data, like billions, millions of data points at a time, and then we have to then process and make connections between those data points.
Right.
And during processing, things obviously can go wrong. You cannot build a perfect solution for anything. But we definitely plan to catch those issues, before they are surfaced all the way through the pipeline. And that is why we have purchased, Telmai, the data observability tool. So it is hosted in our environment. That means we don't have to worry about any privacy or security concerns. We have full control over it. We manage it, and then we basically configure the tool to kind of scan and profile our data to find issues. Telma has a good feature called out-of-the-box anomaly detection. So we just have to connect the data sources, and it gives us a lot of insight even without writing a single policy or rule. That is
Nice.
our first level of defense. And then on top of it, we also create more rules and policies that we also run through Telmai. And it's a scalable tool. The size of the data doesn't matter. The underlying engine is built in Spark. That means you can scale it to any level. And then the quality of your data is basically as good as the rules that you create. So it puts the onus on you to be able to own and create those rules with the knowledge of the data that you produce, right? Rather than relying on another vendor or third-party tool or something like that. Sorry, I missed the original question.
Yeah, but
I
I'll
probably
add it.
might have digressed from it a
Pankaj,
little bit.
as much as I love to hear about Telmai, I think we missed the memo. We don't really. It could be open-ended, like around what was your architectural challenge, even outside of the tools that Telmai solves. So, just to keep the spirit of this vendor agnostic. So here. I think I can speak a little bit, but ZoomInfo's challenge was their data ecosystem was pretty heterogeneous. Pankaj, I remember that, right? Like
Yeah,
your
that's
challenge was not
that's
just
what I was getting
site.
at. Yes, yeah. So we are a multi-cloud setup. That we are in AWS
Right.
and GCP, and then even like within that periphery, we have other solutions such as we have Snowflake, we have BigQuery, we have other data analytics solutions as well. Because of a long history, so we build those data processing system over the time, and in the process we ended up using a diverse set of technologies. So it's not easy to kind of kind of get a tool like a data quality tool and then plug into your data assets that are spread across multiple clouds or two clouds. So that is the main challenge, and then also the proprietary solutions kind of provides the accessibility to the data in a different way than just like data lake kind of a solution where the data is just sitting there and you can go and do whatever you want, right? So that was the main challenge, in doing data quality. So what we earlier ended up doing is basically build in-house processes to do quality checks on data, which can be very challenging, right? So then you have to build something that works on that and this and everywhere. You have to scale it. You have to own not just the functional aspect of it, but you have to also host it. You have to own the infrastructure and scalability aspect of it as well, which is unnecessary because it does not add real value to the business. If there are tools out there that can do it for you, I would just recommend use those tools. Operationalize them by yourself to mitigate any security concerns, and just scale that solution on top of your data instead of trying to build a very standard solution that is already out there by yourself.
And
Very cool.
Pankaj, a follow-up here. Did moving to iceberg or open format made, and it's for everybody, does it make it harder to achieve data quality for, because I was in the, I've been long enough, I was in Oracle days. Data quality existed always. But that time we had fixed schema, fixed table sizes, everything was very
Right.
controlled. Then we moved to big data. Now we are moving to open format. What does that do to our data, right? Like we are losing, I feel like we are losing control on the quality of the output the bigger we move from. Over to you folks, because you are in front and center. I know part of this you solved, but did it make it harder for you when you adopted open data formats?
Well, you can
Well,
postpone it. That's
good.
one of the things.
I
With
see the
open standards,
excitement,
now you
so we
can
have good
postpone it.
answers.
That's one of the things I see. So these open table formats, they handle schema evolution really well. But
Yeah,
if you don't care, okay, you could go forward and postpone data quality. But at some point, it will come after you when you start to operationalize the data and serve it to business users. But maybe back to you, Pankaj.
Yeah, I mean, I was thinking the exactly the opposite. It's not making anything hard per se. It's expanding your horizon, right? So going back to the data quality use case, let's say all your data is in Iceberg. Yes, you can use data quality tools, but then you can use other interfaces to just run queries, do data analysis, and find data quality issues that way, right? So you're not just limited to a specific tool to do data quality. And because it is in an open source format, that means you can pretty much bring in any interface, right? You can, if you're in Google, you can just connect your BigQuery interface or compute layer to your Iceberg data sitting in GCS. It doesn't even have to be in BigQuery, and you can run your queries there. You can do the same thing with Snowflake. You can do the same thing with Starburst. It's the same data. It just expands your horizon, and so I think it makes things easy and not hard.
I see.
Yeah.
So what you're seeing is you are seeing more and more technology solution. If you have data quality as a priority, especially ZoomInfo, that's a top thing for you folks. It's a business driver. There are much better technologies to achieve it with open data formats than if you had to go with any other approach like warehouse and so on.
Exactly. Yeah. Then you're not limited to just one solution to query and access that data or to find data quality issues, right?
Gotcha.
Yeah.
It
Scott,
also-
what do you think?
Yeah, I've got a ton of stuff to think about this. I mean, lots of words coming out. But like, if you think about it, right, like the data warehouses themselves, like you had fixed schemas, you could evolve those schemas, and it required you to, alter table and add defaults and do all this other stuff that was not necessarily, the standard if you think about just a data lake itself. And so like, as we move into like the world of like houses and like, anything else with houses in the future that we're talking about, like, data estates, I think, Pete, you were calling it before as well. Like, it's like, what makes it nicer than just like the house? Like, how do we create, these, these monuments to like the data, like what it could be. Like a lot of that requires us to think ahead. And so like there's like, if we talk about like, real time, I work a lot in real time. Before things land, you can fix data problems as long as you understand what it is that you're capturing. And like, I think there's going to always be harder problems to solve if we think about, indexing documents. But if we think about like, data that's flowing for analytical purposes, traditional kind of like, I guess we'll call it old school analytics at this point now, like things that are leading to like, business intelligence rules, things like that. But for that, like, if you think about, some of the problems that used to arise, right? It's, I have schema on read and this didn't work. It's corrupt. What do I do? How do I fix it? Those problems are harder from a data lake perspective than if you have, an actual, schema. And so I think like with, Hootie, with Iceberg, with Delta Lake, any of the like the lake, Lakehouse formats, you have those schemas that make it, kind of that, hybrid between, the best of both worlds, right? It's, unbounded scalability with, precautions as long as you're following them. Like you can always, circumvent the rules, but if you're following the rules, it solves a lot of problems that used to come up with just like, just this field type changed. Like those were huge problems to solve, especially like in a streaming landscape. Like it's like, oh, I expect this to be numeric, but now it's for some reason it's switched to a nested message type. Why is that? We don't know. Let's go figure it out and let's go track that down. It's a lot harder during an outage. And so being able to, rely on data as it's flowing, as it's coming through. I talk about this like I talk about it in like the Delta Lake book as well, but it's if there's things that you can do, using Avro, using Protobuf, like that allow you to land data in a very specific structured way, that can also get you, it can help alleviate some of the pain of trying to track down data quality issues later, because that's more expensive, like trying to figure out why and when things broke, unless you're doing essentially like, in-stream or in-process quality checks, and also, pulling the plug and, failing the process to prevent things from going downstream if they're not good enough. And that's where I see some of the, data quality going now, where it's, if we think about things as end-to-end kind of open streams, whether or not these are batch jobs that are connected through workflows, or if it's streaming jobs, essentially just kind of forking off to different, processing stages across like the medallion architecture. It gets a lot more complicated if you don't have those kind of rules of, engagement set, from day one.
If I may add a quick point, and those are all great points.
Yeah.
That, people always think about schema enforcement, and I think about schema evolution, right? So enforcing schema is good, but it kind of creates a bottleneck on all the sides of the data, right? So schema evolution provides the data producer to make changes at their cadence or convenience, and the data consumer can basically adapt to those changes or start using the new features that are added in the data at their cadence, right? So they don't have to be time bound, or they don't have to be decoupled with the producer of the data and make it like a multi-system level effort just to add a one attribute. So that's why schema evolution is very important. Pretty much all the, especially real-time technologies such as Kafka already supports it. You just have to use it. It is even more critical in event-driven architecture, where you have many producers, many consumers. Adding a single attribute breaks the whole system. And it could be, schema evolution could as well be achieved in batch processing with open source format, right? One thing to add is that when we talk about schema in data warehouses or open source format, it's not just about primitive types, right? There are complex data types that you can add in, literally put in a long JSON document as one column or one attribute if you have to. I'm not recommending you should do that, but yeah, if you have a use case, it also supports that. So it's very flexible.
I have seen that, to be honest. I have seen a single snowflake attribute, column attribute. The whole JSON object was into that single column. But who knows? That was a use case. Maybe that was the right thing for them to do. But technology today supports that, so why not? Yeah. Yeah, I think one thing I want to quickly think about the way I like to summarize things. So I walk away with a lot of action items myself. So what I'm hearing is that with open format, we got more technologies to do data quality the right way. But at the same time, the onus is on us now, especially the architects and the technical team, to make sure they follow that best practices guidelines, that when there is a schema change and there's an impact, and when there is any updates to things that could have business impact, you need to put in those guardrails more differently, but definitely even with the open data format. So is that a good way of putting? And Pete, if you want to add in, definitely
Yeah,
add an item
I
too.
think it's a nice way. The only nuance is I see with batches, batch-oriented data processing, you have the luxury to later in time fix it and then retrospectively fix all the data quality issues, because usually you get the entire state of what the application serves to you. With real time, I see it really different, because if you screw up, all of these messages start to drop and you need to debug, and consumers will complain. So that requires you to more conform to standards you set. Well, with batch, you can postpone and have more luxury in your architecture. So that's and there's another nuance. We mainly now talk about technical data quality. There's as well functional data quality, which in my view is highly subjective. Very much depends on who examines and studies that data. But that's also a very important subject you need to manage. But that's often more postponed. So first we take the technical data, inspect it, technically validate it, and then after comes the functional part.
Yep. One quick question from my end, since we've been, obviously seeing so many announcements from different vendors talk about AWS, Snowflake, Cloudera. We've seen tons of announcements, even the Databricks acquiring Tabular, and obviously, Ryan being a key part of Tabular, now being obviously the part of Databricks. How are you all seeing this impacting the space in general as well? Like, because it's when the tech giants kind of start talking about that moment where now open table formats, everyone wants to learn more and more about it. How are you all looking at it? How do you all see the space moving, say in the next 6 months or 8 months? What are your thoughts about that? Pankaj, from an enterprise point of view, what do you see?
I mean, there are two aspects here, right? So why Databricks acquired Tabular, right? So there is the business aspect, which is obviously to monetize a future looking, forward looking, capability. But in terms of as like customers, what would we get out of it, right? So definitely, Iceberg, just have the format is not enough, right? You still need a lot of things built around it to truly use it. And even today, if you just use Iceberg and pick and choose your technologies, it is still a lot of work, right? So that could still be standardized. At the end of the day, you have data and records and attributes flowing through your real-time, pipeline or batch pipelines. So what you want to do with that could simply be simple configuration, for example, right? You want to do this with that attribute, that with that attribute. You want to do some transformation. That could all be standardized. And at the end of the day, it could just be a plug and play kind of a thing where you just say that, so here's my input. I want to anonymize my data. I want to do this with my data. And finally, I want to store that data into Iceberg. And then I want to query that data. So that could still be provided as an end-to-end solution. I think that is what would basically most of these commercial vendors would try to do. And but again, this is just a guess for now. But yeah, monetizing the tool and the capability is the primary goal here. But we all would also get benefit out of it by getting a standard solution.
Fantastic. Scott, what do you think in your work? You can also view it as an enterprise because you work for a big tech giant, big enterprise company. So yeah.
Yeah. So I think with this, I mean, everyone's been using S3 essentially. Like it's almost ubiquitous. I can't talk. But everybody else has, cloud storage. But every single pipeline that is going to do anything in the lakehouse is essentially always taking data, dropping into cloud storage, going from cloud storage, and then converting it into a table format. And so if that is just being dropped in as a specific table format, that's then interoperable. If you think about not Icehouse, Xtable, and you're converting from type to type to type to type, it doesn't really matter what is stored in S3. Like if you think about like S3 tables and like that announcement, for example, you now have essentially, with some strings attached, you have, auto compaction and everything else like that you want on, on your Iceberg tables. And then you have the ability to do anything else you want with it to feed into like, your open architecture, whatever format that you are using, or if you're using multiple formats, you can take the best of both worlds. Like every lakehouse format not everything has feature parity. And so, in certain places, you're going to get better indexing. You're going to get better, types, different heuristics like Bloom filter indexes, things like that. And so depending on what you're using, this then allows you to achieve those those results while also skipping some of those some of those steps that are required for every single job. If you've got hundreds of thousands of pipelines, then you're saving hundreds of thousands of jobs to be able to just write directly. So I think that we're going to see a lot more of that like moving forward as well. So whether it's, you think about like Warp Stream, right? It's, Kafka over S3. It's, this is happening.
Okay, fantastic. Mona, what do you see as a vendor? I'm pretty sure you've seen the impact and the customers talking about it, right?
Yeah, I'm definitely seeing this, right? As Scott mentioned, right? I have a very straight, I mean, when I talk to customers, it's literally like you can take, they have Iceberg hoodie to some extent, but Delta has been very prominent in the past. Now more and more we hear Iceberg. But really, that's the simple thing. They push things on, whether it's blob storage, whether it's GCS bucket or S3, but they're pushing that data and they're trying to, whatever their choice, sometimes even which cloud vendor, hyperscaler you're going with is way beyond the team that's building. That decision is made. So what I like is even with the adoption of this, there's an ecosystem that is built out, and all of these big vendors are the competition with themselves is working for our customers in general, because a healthy competition is pushing hard for better products, and each of them are now neck to neck in like everybody wants the compute to be in their system. So they are pushing hard on supporting this open format, but providing services that make accessing compaction and other things. And that again brings back to our topic. That's why everybody being supportive of the open architecture is in the best interest of the ecosystem, because you're giving the vendors the freedom to go with whatever they have. They have credits for AWS, use them off today. Tomorrow you can use GCS or Microsoft or whatever be the choice. But I'm seeing that it's all, of course, some of us might be concerned that it's 2 or 3 big vendors are trying to drive open format. It's only as open as these vendors can drive. But in the end, I do feel that there is an ecosystem that's built for the interest of customers.
Nice. Pete, what is your customer story?
My customer story, all customers I work with, they all, without any exception, I could safely say, use Delta as their default open table format. It's because of Databricks, Microsoft Fabric. However, I must admit Microsoft Fabric now supports Iceberg as well. We see more and more interest from our customers in the Iceberg format. I would not be surprised if Microsoft changes also their architecture in a way it becomes even more open. So you have flexibility to choose. If you like Iceberg, you go for Iceberg. If it's Delta you would like to work with, you choose Delta. So there's flexibility, even making a more open architecture than in that respect.
Nice. Since we are on the topic of even Delta, and I know Scott recently came up with the book Delta Lakes. And Scott, this is just specifically for you.
Sure.
About the book, what can people? I know there are other authors like Denny Lee, Tristan, very good friends of mine who have also co-authored the book with you. So what can they expect? Why should they be reading Delta Lake, the definitive guide? And how will it help them learn more about the space?
Yeah, I think, I mean, if you read the book, it doesn't really matter if it's just delta either. Like a lot of the lessons you learn in any book are essentially like, you're not just going to go through any book and say, here's all these very specific things to this one format. Like here's the delta protocol, here's X, Y, and Z. While we do talk about that, a lot of it is like ways of working. And so like when we talk about like, medallion architecture, like it's not as in-depth as what Pete goes into in his book, but it's kind of laying the groundwork for people to think a little bit differently about how they build things.
Exactly.
We go through, data sharing and with Delta Share. And before we talked about sort of why is zero copy important? We didn't say the word zero copy, but in a lot of cases, it's like, here's the ways that we should be working to reduce compute, to reduce complexity. And a lot of times, books are essentially a story that kind of goes beyond what it is that your subject, matter is. So while we talk about Delta, we also talk about the Rust ecosystem for people who want to get into Rust, as a lot of things are moving, especially like in the data ecosystem, it's moving into Rust as well. And so there's a lot of things you can learn. And also we went through a lot of effort putting together Jupyter Lab experiments for most of the book, so that people can go through and actually run everything without having to really be an expert or understand how to do it either. And so for that, we all learned something, but a lot of us kind of got into this because it's like, you don't make money off of books, but you do it for the love of something. And
yeah, exactly.
I've been using Delta Lake since 2018. And so it's like, cool, like I'll totally write this. That'd be great. But
no, love it.
Those were great. So
that's awesome.
So, actually, the thing is that you don't, although the cover says Delta, you could be an Iceberg user and you could still learn a lot more about the best practices and how to do it. So that's a pretty good takeaway.
It could just been this,
Oh, awesome. So I don't know, Ravit, how are we doing with the time? Should we put the last question, which is what is your one thing we like to do is, if the audience have to walk away with something actionable as they adopt or getting into the journey of open data formats, what is one or two key takeaways that you want them to get from this podcast?
I think who wants to go first? Maybe Pankaj?
Okay, I'll go first. Yeah, so in terms of adopting the, some of the open data formats that are out there, since we are mentioning or talking about Iceberg today, I'd go with Iceberg. What I'm gonna suggest or advocate for here is that if you are not using any of the open source formats or data formats, I think you should plan on doing that as soon as possible. It doesn't have to be Iceberg, it could be anything else. But I think that is the first point that you should take, because it's already too late if you haven't done that already. And then, look at the standard practices, read books such as the one that Scott has written on Delta Lake, as also, Iceberg. First, understand the concept. What is in it for you, right? Why are you doing it? Why do you want to do it? Understand the concept, and then see how you can package your data, and then how you can operationalize that as Iceberg or any open source data format. And then think about the customers or consumers for that data, right? Not just as a data producer or data product builder, but also think about the persona that are going to use that data. Is it going to make their life easy? And in order to make their life easy, what else you need to build around that data? So I would say also start thinking about it. Don't just build a data product that nobody is going to use, or it's going to be hard to use for anybody unless they build another process to move it somewhere else and then start using it. Also think about some ancillary things such as data lineage, record level lineage, which is an architecture that I came up with. We started making some progress in our data ecosystem where every record has a lineage ID. Even when that record flows through 10 systems, it carries over the same lineage ID, then we can trace it back. And so once you have that built into your data, then you can generate all sorts of lineage views, right, to be able to troubleshoot data issues. Going back to data quality is another, I would say, non-functional requirement that you need to take seriously, right? Not just on your final output data, but just build like data quality gates, which is also another initiative that we started. So what we are doing is we are putting data quality gates in every single stage of the pipeline. Mm-hmm. It's not just the output, but we are also doing data quality on intermediate data so that we can stop bad data going all the way to the end of the pipeline where it could be exposed to our customers. So I think using open source data formats would basically enable all these, different non-functional requirements that you have to build on top of your data, and also think about, Pete mentioned about open data catalog or open standard for data catalog, which I totally agree with. So I think somebody should build it, but also think about, cataloging your data, as soon as you publish your data products. And there are open standards for data contracts out there, not data catalog per se. There are open standards for data lineage. It's called open lineage, but it only supports data set level lineage, not record level lineage. But it is still better than not having any lineage at all. So those are my recommendations. When you start that journey on going with an open source format, also think about these non-functional requirements and ancillary things that you can build easily if you go with an open source format.
Nice. That's very detailed. Thanks, Pankaj. Pete, what do you think?
I think an open architecture is extremely important because things move very fast. So my best practice I would like to give to all listeners and people out there is try to make it vendor neutral or vendor agnostic. So use open standards, but metadata even more important. So make things metadata driven and maybe not go too deep into the specifics, maybe of certain open table formats, because things could still change. And if you went too deep, it's hard to move out. So you need to build that tiny abstraction layer yourself. And the goal there is the answer is make it metadata driven.
Amazing. Thanks for that quick suggestion and quick feedback. Pete, Scott, what do you think?
I'm like a hybrid of both Pete and Pankaj. I think like if people get anything out of this, it's that like if you're still doing things that are fragile nowadays, that there's ways of working that don't require you to spend as much time fixing things that are broken. So whether it's keeping data quality gating between steps within like a workflow's journey, do that. Whether or not it's actually having like appropriate like dynamic up-to-date metadata about things in your catalog, do it. Like a lot of those things are always like, depending on the size of the company, if it's a smaller company, I feel like there's a lot more kind of like rigor. If it's a larger company, a lot of people are kind of like, well, that's their job, that's their responsibility. Yeah. It's an engineer's responsibility to be able to understand what it is that they are doing and getting paid for. That's my 2 cents for that. Like it's kind of a definition of done for anything that you do, right? Whether it is I have lineage, I have checks and balances for like the quality of the data. Here's the expectations. Whether or not things are semantically tagged. It's not like, I think data used to be something that it's like you didn't have to really do a ton with. Like, I mean, we've always done a lot with it, but you didn't have to try as hard. I feel like nowadays, like in order to be able to, have all the kind of connective tissue into the rest of the systems that we were building nowadays, there's a lot more required to be able to make it easy to work with that data. And so starting off and kind of progressing through is a long road, which eventually gets to full automation. And without a lot of those steps, what you are automating might not actually be there, like, real. And so it's, one of those things where there's, if people haven't done anything, there's an opportunity to start. It's a long journey, but it's worth it. And if you've already started, that's great. Just don't skip steps. And that's my 2 cents for the year. So happy 2025.
Wow.
Love it. This is fantastic.
I want to add something to this.
Yeah, Mona.
So I'm putting my business hat on, and everything that I'm hearing now really translates to cost. So if you think about open data formats, and I've had this conversation with many folks, people need to realize there's a huge underlying benefit of cost. And everybody knows here that I'm a big fan of this type of paradigms, because there's a lot of benefit. One is like, your storage is cheaper, but the inefficiencies around querying data, the inefficiencies around everything that you explained today, all of you brilliant minds together, really translated in my head to dollar, because you were building faster products, you're building more reliable products, you're building an architecture that fuels innovation long term, mid term. So all of that, and I've seen an increasing pattern within our customer base, and Pankaj, you might be able to add here, but people are projecting high dollar value savings by moving to open formats and open architecture. So that's one of the takeaway that cannot be discounted in this conversation. Anybody who's looking at that, that it's not just like, oh, we want to build an architecture that's a shiny ball and being spoken about. There is really measurable value out of this approach.
Yeah, I think some companies are already doing this analysis. So at a conference that I attended in Boston a couple of months ago, so there was some benchmarking that somebody shared, or some company shared, that for 1 terabyte of data, it's $5 versus 25 cents. If you use a proprietary compute engine versus S3 or GCS with Iceberg as the data format and some compute layer on top of it, that's a huge difference. $5.25.
Mm-hmm.
Yes. Fantastic. I mean,
That's
this
awesome.
has been so enlightening for me. So I'll let Ravit wrap up. It's his show, but
Yeah.
definitely a vote of thanks to all of you awesome panelists.
Thanks.
No, what an insightful discussion for sure. And huge thanks to obviously all the brilliant guests, Pete, Scott, Pankaj. You all have been fantastic in terms of, talking about so transparently about the experience in where the space is moving. Talk about the implementation part. Pankaj, you were amazing. And Scott, obviously talking about, the in-depth architectural things. And then Pete coming from an experience of not only just talking to so many customers, but also writing book and the process, and Mona obviously the business. So it was great to co-host with you as well, Mona. Can't wait to see where the space is moving, but also big thanks to our viewers who have joined us today. And I hope you all enjoyed the thought-provoking conversation full of actionable insights. Feel free to reach out to Pankaj, Scott, Pete. I'll share the LinkedIn, I'll tag them so y'all can follow them, y'all can learn about the books and the different content that they share on LinkedIn. But once again, thanks everyone for joining us today, and such a pleasure to host you on the Ravit Show. Until we have a discussion again. Thank you.
Thank you,
The
Ravit.
honor is mine. Thank you.
Thank you, everybody.
Bye,
Have a good
everyone.
Thanks, everyone.